right, hey, good morning, guys. Today is Wednesday, uh, May 20th. We're right here, start of our new calendar here. We're going to be doing lesson 20, starting lesson 20, page 403 through 406, getting started here. Now, what we're going to be doing is we're looking at multiplying fractions to find area, learning targets right here. Okay. Well, if we think about what we already know about area, we know that length times the width gives us the area of a rectangular figure, right? A square or rectangle. Okay, we can find area of a rectangle by multiplying length times width. We know this. Okay, we know this. We're going to apply that same stuff. We're going to use these concepts. So let's look at this problem here. Let's make sense of it. Then you should pause this and give it a shot and try to solve it. Okay, and what you don't figure out, then come back and obviously check your work and then make adjustments to it. It says Mr. Thompson designs a 1 mile square park. Okay. He makes a square, so then he makes a square with 5/10 mile sides on his design for a dog play space. How many square miles of the park does he use for the dog play space? So the park itself is going to be 1 mile, 1 square mile. Now, if it's 1 square mile, that means the length and the width have to be 1 and 1, right? So one time, well, it doesn't have to be, I guess theoretically, but the idea is that it's 1 and 1. That's the easiest way to do it, right? So it's 1 and 1. Okay, so it's 1 mile by 1 mile, so you have 1 square mile. Okay, within that, in that space, he has taken a section of the park. 5/10 is the length, 5/10 of a mile is the length of one side of the square for this dog park. So because it's a square, it's gonna be 5/10 by 5/10. That 5/10 by 5/10 is gonna be part of the park. Now we don't know exactly where, but the idea is when we draw this, it doesn't matter where it is. Draw it so that and model it so that it makes logical sense, right? I want you to pause this video now and go ahead and problem solve. All right. Let's go ahead and make some sense of this here. We have a 1 square mile park, right? So I'm gonna go ahead and just gonna draw a square, well, close to a square. We're gonna assume it's a square, okay? This length here, this side here is 1 mile. This side here is 1 mile. Therefore, it's a 1 by 1 mile park. Therefore, we have 1 square mile. This whole thing equals 1 square mile because it's 1 mile by 1 mile. Okay, pretty straightforward, nothing new here. Okay, but here's the thing. He makes a square within this. A square within this that is 5/10 by 5/10. So all sides are 5/10. So it's 5/10 by 5/10 because length times width, right? Length times width equals area. So if I go ahead and I draw this square here, approximately, okay, and I say this is 5/10, and I say this is 5/10, that's what we're talking about here, right? This length here and this length here, they're both 5/10. Cool. Well, because it's 5/10, we know that there are going to be 10 parts going horizontally. And because it's 5/10, we know it's going to be 5 of 10 parts. So we know that if I'm going to just draw this out real fast, 2, 3, 4. Just going to put this one in there as well. Okay, so we have 1, 2, 3, 4, 5. Good. 1, 2, 3, 4. Not perfect. That's okay. All right. And so then we're going to do the same thing this way. You don't have to do all this. I'm just doing this to help you guys see. 2, 3, 1, 2, 3, 4, 5, 4, 5. And this will draw 4 more. 1, 2, 3, 4. Well, what should have happened when I did this is that it should have created a 10 by 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, right? So we know that we just broke this up into 10 columns and 10 rows. So I guess you need to think about what is the value of 1 square then? Or how many squares are there total? Well, if that's 10 by 10, we know that we have 100 little squares, right? That means we have 100 little squares. That means this one little square here, is equal to 1/100th, right? I'm gonna use a different color because that is not dark enough. I want to use a color. Here we go. 100th, right? Okay. So what do? We have 5, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Okay, correct? This is our square. Okay. So what we're looking at here is that the length, our length, so if we call this the length and this the width, let's say, okay, if our length is 5/10, and we're going to multiply it by our width, which is 5/10, okay, the question is, what does this equal? Well, if I know that each of these squares is 100th, I know that I'm going to be looking at a total of the value of each of the squares is 100. So we're going to get our answer in how many of these squares are there. So we're going to be looking at this as hundredths, right? So the idea is I have 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. That's a 5 by 5 array. 5 times 5 is 25. Okay, so the idea of the answer would be we'd have 25 hundredths. 25 hundredths is the answer to how many square miles. Okay, so we'd put 25 hundredths miles squared, right? Okay. Now, we can look at this a lot of different ways as well. Let's go ahead and extend our thinking here. Hopefully some of you are seeing the patterns that should be emerging when we start multiplying fractions by fractions. Also within this, some of you might be saying, well, hey, Mr. Smotches, 5/10 is just a half. So why can't I just do half of a half? That equals 1/4. And you would be right, because guess what? 25 hundredths, well, 25 hundredths is equal to 1/4. We're talking about fractions, right? So you're not wrong. This is a great way to think about it as well. Totally do that. Don't feel like you can't think about it this way, because ultimately we are going to want to be simplifying things when we have the opportunity to. We can also get it from this standpoint, just visually speaking, to prove that this is 1/4 of 1/4. If we look at this and we break this straight across here and straight across here, we can see that we have 25 here, 25 here, 25 here, 25 here. So we have 4 equal sections, don't we? 4 equal sections, and 1 out of the 4 sections is being shaded in. So that would prove that it is 1/4 as well. So there's a ton of different ways of thinking about this. And we're getting to the point now where we've been doing this long enough that if you haven't seen the pattern, hopefully we're going to reveal that now. The idea is that multiplying my numerator by my numerator gave me 25, right? Multiplying my denominator by my denominator gave me my 100, correct? Oddly enough, that's all it takes to multiply fractions. As far as fractions by fractions, is if we just multiply straight across. That's literally all it is fractions by fractions, right? Now it gets a little bit different when we start talking about other with mixed numbers and stuff, but as fractions by fractions, hopefully we're seeing that pattern. Now, we still need to understand exactly what it's representing and things like that, but this is what it means. This is just the shortcut, right? to make our life easier. Okay, let's keep going here. All right, on to the next page here. There's some questions. Says, explain how you found the area of a park used for the dog space. Well, again, I'm not going to go spend a lot of time on that. Literally, we just spent a bunch of time talking about it. You should have had your own strategy. So go ahead and write in there your thoughts and how to approach that. But we're going to do this look ahead part here. It kind of bled through. I'm sorry about that. Okay. Okay, it says, suppose you want to find the area of a rectangular section of the park that is 3/10 of a mile by 3/10 of a mile. So last time it was 5/10 by 5/10. Now it's 3/10 by 3/10, right? You can find the area in different ways. Okay, tile the section with unit squares. The 1 mile square park is divided up into 10 columns and 10 rows. That's literally exactly what we talked about, right? 10 columns, 10 rows. Okay, so that one tile is 1/10 by 1/10 mile, right? One column, one row, each of them are 1/10. 1/10, 1/10. Therefore, one of these is 1/10 by 1/10. Okay. What is the area of one tile? The area of one tile of one of these one little tile here, right? The area of just one of those little things, okay, is going to be 1/100th, like we talked about before. Okay, one little square, because this is 10 by 10, right? There's 100 parts here, so one would be 1 out of 100. How many tiles are there in a 3/10 mile by 3/10 mile section? Well, again, here we have 3/10 and 3/10. So of the section, there's clearly, it's a 3 by 3 little array, because 3 times 3 is 9. And and each size of are hundreds. So therefore, there are 9 out of 100, or 9/100ths in their size. What is the area of the 3 by 3 section? Sorry, I did this wrong. How many tiles are there? There are 9 tiles, and the answer is 9/100ths, right? So I did that wrong. Getting ahead of myself. Okay. So again, using this strategy, we can hopefully start making more sense of this. This is just really setting that foundation up for the future here. Okay. You find the area by multiplying the side lengths of the section. So 3/10 times 3/10, multiplying the fractions of the area. Again, we talked about this. If we multiply across here, we have 9. Multiply across here, we have 100. Okay, so the area of the section is 9/100ths square miles. Okay, pretty straightforward. I'm not worried about the reflection part right now. Okay, next page. Okay, area model. I'll give you, just for speed this video along here, you obviously can write your own definition, things like that. Here is some examples here. You can pause the video, take down what you need, make your own examples, do what you need to do to help yourself out there. Okay, all right, there we go. If that was too fast, obviously, go back and pause the video. I'm not going to waste time waiting for you. Yep. So again, this is examples of area model. We've talked about area model a ton of times in class, so it shouldn't be anything new or special. But the idea is that we're just applying it now to fractions, right? So let's do number 2 here together. It says the area of the whole square, this whole square, is 1 square mile, right? 1 mile by 1 mile, 1 square mile. What is the area of the shaded part? Well, we got to figure out how much is shaded by how much is shaded, right? So there are 3, 1, 2, 3 across this way, right? And there's 1, 2, 3, 4, 5 across this way, right? Okay. Okay. But remember, we talked about the area model. The idea is that there are 5 rows and each row is a 10th, right? A 10th. This would be 5/10. 1, 2, 3, 4, 5, right? There's 1, 2, 3, 4, 5, just showing you that this is halfway. Okay. And this would be 3/10. Okay. So now some of you guys say, well, Mr. Smarts, 3 complete tenths are not shaded. And I would be like, yes, you are right. This is what we've talked about before, how this is all the 3/10, right? This is all the 3/10, and it'd be multiplied by the 5/10 And what we care about is a fraction of a fraction, like we talked about in the last lesson. So this is 3/10 of 5/10, or 5/10 of 3/10. So this area right here, just this area right here, is all that matters, okay? So when I go ahead and multiply this, I have a problem that's going to be 3/10 of 5/10, or 3/10 times 5/10, which again, if we talked about what we talked about before, we're going to multiply across. That gives us 15/100ths. And to prove this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just prove that there's 15 of them. And the size of one square is 1/100th, because there are 100 of them. So therefore, we have 15/100ths as far as that size goes. Last but not least here, I want you to apply what we just talked about and solve this problem here. Okay, solve this problem here. Down here it says check your answer. Remember, we check our answers by using other logical strategies. We can use estimation. We can use a lot of different skills and strategies to do that. It's kind of tough to use inverse operation kind of here. But again, if you think about 6/10 and other forms, there's a lot of different ways you can check your work just to make sure that it makes sense and is accurate, okay? Like I said, using estimation is a good way to quickly check that. Don't stress about this too much. You should be able just to confirm that your answer actually is correct. So any way you can do that to prove that is good. But really focus on this one here, okay? So if you worked with me, that's all you have. That's the rest that you have to do completely independently today. Should be pretty straightforward. I think we're going to be okay. Looking forward, guys, on the schedule here. We're going to continue on tomorrow, and then continue, and then eventually we're going to start skipping some sections because we have just so much to cover. And so, yeah, I think we should be fine though. I will be online later today at noon. So if you have questions, don't hesitate. Don't fall behind. This is a whole new packet, right? So, don't fall behind. Don't fall behind. Don't fall behind. Some of you guys did a great job not falling behind on the second round. Continue that. Don't slack. All right. Proud of you guys. Talk to you later.